All right, exam time is just around the corner, so we're going to make every single second count. Let's do a super fast, super focused revision on the stuff you absolutely need to know. You ready? Let's dive in. Look, your Term 1 exam, it covers a ton of stuff, right? From integers to graphs. But here's the thing. Instead of getting bogged down in all of it, we're going to zero in on the key concepts and, more importantly, those common, tricky questions that can really catch you out when you're under pressure. So here's the game plan. First, integers. Then we'll jump into algebra. After that, we'll hit decimals and rounding. Then on to sequences, and we'll finish up strong with graphs. Simple as that. Let's get going. First up, integers. This stuff is the foundation for so much of what you'll do later, so let's make sure we are absolutely solid on a really key skill, mastering the laws of indices. Okay, so check out this first rule. It's pretty simple. When you've got a power raised to another power, you just multiply the exponents. So 3 squared to the power of 3, that just becomes 3 to the power of 2 times 3, which of course is 3 to the power of 6. See? It's just multiplication. Okay, that seems pretty straightforward, right? But here's the question that loves to pop up on exams, just to check if you're really paying attention. What happens when that power isn't a 2 or a 3? What if it's 0? And here it is. This is the one you gotta lock away. Any number that isn't 0, I don't care how big or small it is, if you raise it to the power of 0, the answer is always 1. It's not 0, it's not the number itself, it's 1. Simple as that. Just remember it. All right, moving on to section 2, algebra. And listen, the whole point here isn't just about finding x. It's about the process and the absolute non-negotiable rule of keeping your equations balanced every single step of the way. So let's take a look at a standard equation. 3x minus 5 equals 10. Our mission, right, is to get that x all by itself. First things first, we got to deal with that minus 5. How do we do that? We add 5 to both sides. That gets us to 3x equals 15. Now, to get x totally on its own, we just divide both sides by 3. And boom, there's our answer, x equals 5. You see that? Every single thing we did it to both sides. That's key. Okay, so the process is pretty logical, right? So what do you think is the number one most common mistake that trips people up and gets them the wrong answer? Well, here it is. The biggest mistake, hands down, is forgetting the golden rule of algebra. If you add 5 to one side, but you forget to do it to the other, the whole thing is broken. The equation isn't equal anymore, and your answer is going to be wrong. Guaranteed. Every single time. All right, topic number 3. Let's talk about decimals and rounding. I know, it sounds easy, but you know how exam questions can be. They can get a little bit tricky. So let's get crystal clear on the difference between rounding to decimal places versus significant figures. Okay, this slide lays it out perfectly. Let's take the number 15.735. Now, if the question says round to 2 decimal places, you look at the third decimal place, which is a 5. That 5 tells you to round up, so you get 15.74. But if it says 2 significant figures, you start counting from the very first digit. The third significant figure here is the 7, and that tells you to round the digit before it up. So the 5 becomes a 6, and our answer is 16. Totally different methods, and as you can see, totally different answers. You gotta know which one to use. Okay, time for our 4th topic, sequences. I want you to think of yourself as a code breaker here. Your job is to spot the hidden pattern, to find that underlying rule that creates the whole sequence. We call it unlocking the nth term. So the nth term is basically a little formula that lets you find any term in a sequence, whether it's the 10th or the 10,000th. So for this sequence here, 5, 9, 13, 17, what do you notice? It's going up by 4 every single time, right? That common difference of plus 4 tells us the rule has to start with 4n. Now just think about the 4 times table for a second. 4, 8, 12. Now look at our sequence, 5, 9, 13. Can you see it? Our sequence is always just 1 more than the 4 times table. That's our little adjustment. So the final rule is 4n plus 1. Done. That's all well and good for a sequence that's going up. But what about the tricky case? What happens to our rule if the numbers are going down? And here's the key thing to remember. A decreasing sequence, one where the numbers get smaller, is always going to have a negative number in front of the n in its rule. Just look at this one. 10, 7, 4. What's happening? It's dropping by 3 each time. So the common difference is negative 3. and that means our rule has to start with minus 3n. The negative sign doesn't change how you figure it out, just the numbers you're working with. And here we are, our final section, graphs. So whenever you see a straight line on a graph, there are two things that really matter. The first is its gradient, how steep it is. And the second is its intercept, which is just where it hits the y-axis. Right now, let's really focus on that slope, the gradient. So, what is the gradient? Well, it's really just a number that tells you exactly how steep a line is. And you figure it out by taking the vertical change, what we call the rise, and dividing it by the horizontal change, the run, rise over run. And that value, that's the m in that famous equation, y equals mx plus c. That m is the slope. Okay, but what about the weird ones, the special cases? What's the gradient if a line isn't sloped at all? Like, what if it's perfectly flat? Or what if it's perfectly straight up and down? And this is something you just need to know. There are two special answers here. For a totally flat horizontal line, the rise is always 0, right? It doesn't go up or down. So the gradient is 0. And for a vertical line, one that goes straight up, well, the run is 0. It doesn't move left or right at all. And in math, you can't divide by 0. It's impossible. So we just say its gradient is undefined. Those are two key facts you've just got to remember for those two special lines. All right, let's do a final super quick recap. Ready? Anything to the power of 0 is 1. Always do the same thing to both sides of your equation. Know the difference between rounding to decimal places and significant figures. A sequence going down means a negative n. A flat horizontal line has a gradient of 0. You got all that? If you do, you're in really great shape. So there you have it. We've just blasted through the key ideas and the trickiest spots from your first term's work. You are now armed with all the key info you need to walk into that exam feeling a lot more confident. So really, the only question left is, which one are you going to practice first? Go get 'em. Good luck.